You've probably written a test that breaks for the dumbest reasons. You change a log file name. Test fails. You swap out a database. Test fails. You update an API endpoint. Test fails again. The problem isn't your test. It's how your code is structured. Most brittle tests come from one source: tight coupling. Here's what I mean. Say you have a function that saves a user to a database. Inside that function, it creates its own database connection. Your test tries to mock the database, but it can't. The function just creates a real one. Everything breaks. That's coupling. Your function depends on creating its own dependencies, instead of receiving them as inputs. This is where dependency injection comes in. Though that name makes it sound complicated, it's just this: pass what your function needs as arguments, instead of creating it inside. Here's the thing. Dependency injection just means passing what a function needs into it. That's the whole concept. No magic, no more, no less. Stop letting the function create its own dependencies. Instead, hand it what it needs. Up front, think of it like a function signature. A function takes parameters, right? You're already doing dependency injection when you write function getData API client, instead of having getData create its own HTTP client inside the function. No containers, no frameworks, no decorators needed. Just passing arguments to the function. When a function depends on something, you pass it in. Your test passes in a fake version. Your production code passes the real thing. Same function, completely different behavior. That's where the power is. That's literally it. Just good function design. Testable by default. Now here's where everyone loses me. Inversion of control. Dependency injection container. Factory pattern. These terms all sound like they require a computer science PhD. They don't. Not all. A tech lead once told me, "You can't use enterprise architecture patterns here." I asked what he meant. He pointed at exactly what we just wrote. Same concept, different label. The jargon exists because big companies need to talk about this at scale. When you're managing hundreds of services, these words become useful shorthand. But you're not managing hundreds of services yet. Your code doesn't care about terminology. It only cares about, can I swap this thing out? Yes. Can I test it? Yes. That's literally all you need. The scary names? Just labels for what you're already doing. Look at this function. It queries a database directly. Tight coupling. You can't test it without a real database running locally. Here's the code. This function takes a user ID, queries the database directly, and returns the results. 3 lines of change. Pass the database as an argument instead. Now the function accepts database as a parameter. In tests, you pass a fake. Your test runs instantly, offline, never touches production data. Before, tests are slow, fragile, stuck waiting on database state. After, tests are fast, isolated, repeatable anytime you want. Same function, different dependency path entirely. That's it. That's the entire pattern. Not a framework, not a container, not magic. Just passing what you need as an argument. This is dependency injection, the scary term for something simple you've already done. But dependency injection only matters when you actually need to swap things out. Most code doesn't need this. Real value shows up in tests. You inject a mock database instead of the real one. Tests run in milliseconds. No flakes. Done. That's the concrete win. Fast, reliable tests. Not reinventing your architecture around it. Some teams inject everything. Constructors with 12 parameters. 200 lines of wiring before one test. That's cargo cult programming. You're probably not building a game engine. Add DI where testing matters most. Where swapping implementations saves actual time. Testing layer needs mocking? Inject it. Everything else? Keep it simple. Don't add complexity just to feel sophisticated. Add it when it solves real problems. You've probably written dependency injection 100 times without naming it. Every time you passed a database connection into a function, dependency injection. Every time you took an API client as a parameter, dependency injection. You knew it worked. It made testing easier. You didn't need the term or the fancy framework. So here's the real takeaway. Stop overthinking it. Name your dependencies. Pass them in. Your test becomes simpler. Your code becomes more flexible. You start moving faster. You're not fighting your own code or the framework anymore. That's it. That's the entire pattern. Once you see it, you can't unsee it. And you'll write testable code without the anxiety, without all that jargon weight pulling you down. Subscribe for more patterns explained this way. Practical, jargon-free, ready to use in production today.